Hi, for today, we will be creating this particular figure, and afterwards, we will also indicate each of the line segments, length, and their respective angles. Added to that, we will be creating this figure in a counterclockwise manner or motion. Therefore, we will start from this point to this point and here, and so on. First off, we will be using line command in creating our figure. Actually, there are 3 ways of creating line here in AutoCAD. The first option is directly typing L anywhere in the drawing space and then press enter. And the second one is by typing L here in the command line or command window and then choose the line command in the dialog pop-up box. The third one is by clicking home and then choosing line here in the ribbon. But on this video, I will be using the first option. So we will be typing L and then press enter. And after doing that, we will instantly see 2 boxes with values with them. These 2 values, this first and second values, will tell us the X and Y coordinate of the endpoint of the line segment we are creating, respectively. That is, when we use comma in between the 2 numbers. Conversely, the first value will signify the length of the line segment, and the second value. Moving on, we will now start creating our targeted figure. And to start it off, let's just type L and press enter, since we will be using line command. And then we will just need to input the coordinates of our first point, which is 1, 1, then press enter. And going to our next point, which is 4.1, 1, to specify this particular coordinate, we will need to input first number sign before typing the X coordinate, which is 4.1, then comma the Y coordinate, which is 1, then press enter. Then going to our third point, we'll just apply what we've done earlier. We will need first to put number sign, then input the X coordinate 4.5, then comma Y coordinate 2.2, and press enter. Then, by the way, I am using the ortho. Ortho basically helps us to make a perfectly straight horizontal and vertical lines. However, it is not advisable to use ortho when working with line segments that has a particular angles or particular inclination from our base angle, since it hinders us to easily maneuver our line segment. So going back in working our figure, the next line segment has a length of 2.3, so we can easily just type in 2.3, then press enter. And the next line segment is quite different from those before. since as you can see, this line segment and this line segment requires to have a 150-degree angle between them. And to obtain this 150-degree angle between them, we will need to identify first our base angle. And then we will just need to find the value of this missing angle, which we will be using to specify the degree of inclination of this particular line segment. So to get this missing value, we can see that from this base angle to this particular line segment, it formed the full arc of a semicircle. And we all know that the full arc of a semicircle is equivalent to 180 degree. So to get this, we will just simply need to subtract 150 from 180. So we will get the value of this as 30. Then going back to our figure, as I said earlier, we will use 30 as the degree of inclination of this line segment. So just turn off the ortho and then type in the length of this line segment, which is 1.4, and then less than sign. Less than sign is used to indicate the degree or the angle or how slanted or inclined the line segment you're working on. So it's 30 in this case. Then press enter. Now we will move on creating the next line segment, which has a length of 2.1. Then press enter. Sorry, we'll just redo. Then we will turn on first our ortho. Then type in the length 2.1. Press enter. And then turn off our ortho again. And here again we are encountering the same case as earlier, wherein we are again required to follow the 150-degree angle between the previous line segment and this line segment we are working with. So applying the same analysis and performing a simple addition and subtraction, we will obtain a value or the degree of inclination of this line segment. And take note, it should be from our baseline. So the value we would get is 120 degree. So just type in now the length first, which is 1.6, then use the less than sign, and then input 120, or the degree of inclination from our base angle. Then press enter. Now turn on ortho again to make our line perfectly straight. And we are now working with a line segment which has 1.3 length. Type 1.3, then press enter. Then hover your crosshair downwards since our next line segment goes downwards and has a length of 1.4. Press enter. Turn off your ortho since we are again working with a line segment that has a particular degree of inclination from our base angle. And again, applying our analysis earlier and then performing some simple math, we'll come up to 100. First type the length, which is 2.2, and then the less than sign, and then the degree for the angle, which is 135 degree. Then press enter. Then turn ortho on. Specify the length of the next line segment, which is 1, then press enter. And again, it has a certain degree of inclination from our base angle. And then the length of this line segment is 1.5. Use the less than sign, and after analyzing and applying some simple math, we will get a degree of 225. In order to get this 45 degree between this line segment and this line segment. So turn our ortho on since we are moving forward to our next line segment, and it has a length of 1 again. Then press enter. Turn off ortho. Specify its length, which is 2.3, and use the less than sign. Now as you can see, it requires us to have 60 degree angle between this line segment and this one. In order to do that, as I said earlier, our base angle is from our east side. So here it is. And from this to this and to this, basically it rotates 360 degree. It's a full circle. So given that this angle is 60 and we've already known that, the only value we need to find is the value or the equivalent value of this arc. So we know that the full rotation on a circle is equivalent to 360 minus this given angle, which is 60. What's left with us is just 300. So this means that this arc is equivalent to 300 degree, and that's what we're going to use in order to obtain this. And to meet this, or to meet this given so let's go back to our figure. Type in 300. Sorry, wait. Let's try again to type in L. And then let's start from the end point. Just type in again the length, 2.3. Then use the less than sign and the 300 degree of inclination from our base point, angle rather, and press enter. Now we are closing in to finishing our figure. And to close this, just hover your crosshair over the endpoint of our starting point. As you can see, there's automatically a green box indicating that it is the endpoint, and just click it to finish our figure and press escape since we are again finished. This is our figure that we've created. It is just lacking on its dimensions. And to create or to indicate its dimensions, we will be using dim command. Just type dim 2 and then press enter. Click here to its endpoint. Up to it is another endpoint, and it automatically shows up its dimensions or length, which is 2.3 or 2.30. And then go here, drag it for a much better view of the dimension. Click it. Now zoom in to check if it's correct. Click it and go to another endpoint of it, and it's 2.10. So far so good, it's all correct based on the figure we are doing or we are imitating. Next is this side or this line segment. Just click its endpoints and drag it outside for a better view of its dimensions. And I just want to add some easiest way of determining dimensions of a line. There are actually various ways of executing the measuring of dimensions. One of this is by typing DLI or the dim linear. This works for a line that is vertical and horizontal, just like this. Okay, let's zoom in. Click one of its endpoint up to its another endpoint, then drag. 1.3. That's correct. And then again for vertical line segment, let's just type again DLI and press enter. DLI or dim linear. Press 2 of its endpoints. Now we have a dimension and currently it's correct. Now for shortcut for this inclined or slanted line segment is dim align or dim aligned. Then press enter. Click 2 of its endpoint, then drag it. There you have it. You have the dimensions or the length of that particular line segment. Another, just type again DIM align, then press enter. Click its endpoint, drag it for a better view of its dimensions. Next is this one. Zoom out. Dim align. Click here and here and drag this one. There you go. Oh, again, I forgot this. 2 horizontal lines. So DLI would do that dimensioning. It's 1. So far, so good. It's all correct. Again, DLI and enter. Yes, it's all correct. Now I've shared with you the shortcuts for measuring the dimensions of slanted line segment, horizontal and vertical line segment. But how about the angle between pairs of line segment? So the shortcut for that is DIM-ANG or DIM ANG. DIM-ANG stands for dim angular. Press enter, then click the 2 line segments and then drag for a better view of the dimension. Just apply it here. Just the same process. Dim angular. Click the 2 line segment that you'd like to measure. And here you go, you have it. This 2 dim angular. Click this and click this to have its angle, which is 45°. And also this one, from the base angle up to this line segment. So dim angular, click this one and this one. Now you have this 45° angle between them. Here too, we will be measuring its dimensions or its angle. So just type again dim angular or dim. Click this and click this. There you go, you have a 60° angle between them. And here it should measure a 120° between them. So just type dim angular or dim ang. Click this one and this one. So in the figure, it is not like this, but it has the same value or same angle between them. So to imitate what's on the photo or our basis, let's just put a little horizontal line. Okay, let's zoom in. And there you go. Now, dim ang command. And instead of this and this, just use this one. This one. So it will show the same measurement. Now what's lacking on here is the label of the coordinate of this point, and this point. So to label it properly, let's just type in the command Mtext and press enter. Mtext will enable us to label some points or some lines. Again, sorry, I cancelled the command. So let's just do it again. Just type in Mtext, then press enter. And there you go. Type 1, 1. Its coordinate. Sorry. Click. Now you have it. Here also, Mtext. And then there you go. The coordinate of this point is 4.1 for its x coordinate, and y coordinate is 1. Then click anywhere. So this last point or the third point has 4.5 as its x coordinate and 2.2 as its y coordinate. Let's type in the Mtext command. Press enter. Mtext. Okay. And there you go. There you have it. We'll just type in 4.5, 2.2 and click anywhere to finalize it. So there you go. Our final output, our final figure. So today we've created this figure and we've used line command, and then we've created dimensions and used various dimensioning tools through various shortcut commands. And there you go. That's all, and that will be all for today. So thank you for listening and watching. Till next time.